Hello, welcome. Thank you for being with us. This panel is part of CASE 2020, which is an open virtual conference for the Canadian Association of Information Science. We will be discussing issues related to lack of transparency in artificial intelligence systems. All the panelists on this panel have either done some research in computation or have studied issues related to social computing or role of technology in the society or quality of data and privacy. We will introduce ourselves as we go. My name is Victoria Rubin. I'm a faculty at FINS, and my doctoral students and I have been working on detection of falsified news and distinguishing with AI systems the differences between the legitimate news and varieties of fakes in news streams. So we have some experience with machine learning and binary classifiers. This is the introductory segment of the panel. It will be followed by 5 talks, and we will follow them with conclusive remarks and open a Q&A session with broader questions to the audience. I will set the scene for this panel by defining AI and machine learning and explaining what we mean by opaqueness in the context of these 5 talks. When people think of AI, many images come to mind, including robotics. In the context of this panel, we're not talking about fully embodied AI. We're talking rather about the technology or machines, computers that are able to mimic humans in terms of their cognitive abilities. For instance, reading and understanding text and making a decision based on what has been learned from data. For example, it would mimic a decision of an expert. Do I want to hire this person or not? And a machine would make that decision based on the personal data in the resume. Or does an instance of an email looks more like spam or not? So we're basically talking about software, we're talking about algorithms, and we're talking about this ability of machines to predict one outcome or another. Sometimes it's called predictive learning. Another term that's closely associated with AI is machine learning. In fact, it's used interchangeably. Machine learning here refers to computer algorithms that improve automatically through experience, or rather through seeing or processing large amounts of input data, such as text, numbers, images, videos, or behavioral data, such as links, likes, and so forth. So what does a machine learning process look like to a group of developers, for instance? Once the problem is clearly defined, let's say, let's identify spams in email versus the ones that are not spams. Then the developing group would look for data and collect data and put it all together in instances of spam versus not spam. Data would be homogenized or otherwise cleared, prepared for processing with AI algorithms or machine learning algorithms. And this is the stage in which feature engineering could also occur if machine learning is supervised, meaning we guide the machines with some salient features that we believe to be indicators of spam. If there is no feature engineering, no additional data put in as supervised data, then the machine learning would be called unsupervised. So once data is prepared, it goes through so-called black box. It's the sophisticated machine algorithms or machine learning algorithms that could make predictions based on patterns that the algorithm finds in the data that's labeled as spam versus the data that's labeled as not. And once the machine learning provides a training model, then the developers are able to test that model with new instances of data to see what kind of predictions the machine would make. And then sometimes there's a possibility of error analysis. Often there isn't because, as I said, black box is kind of hard to see how the machine arrives to a prediction. And then the main emphasis of a developer, technologist, computer scientist is to go from the problem definition to its solution with maximum efficiency and maximum accuracy. So the main effort here is on solving the problem. What is often being overlooked is how the problem fits in the bigger picture. So we arrived to this curious situation from the developer's point of view, rather a conundrum. developers do need input data, but they're not necessarily privy to the decisions with which the data was collected. They don't necessarily scrutinize its quality beyond its fit for training models, and they rely on whatever is good enough and available at the time. On the output side, the predictions are made, but they're often binary and they lack classification. Yes, we hire this person, or no, we don't hire this person. But then the mechanism behind that decision, the motivation and justification, is often veiled. It's either inaccessible because there's a myriad of statistical calculations, and it's either not accessible to a human to trace at all, or if somebody were to try, it would be almost impossible because there are so many sophisticated calculations that are made in the process. So developers often search for better models to train their systems with, such as salient features for supervised classification, but may lack the appropriate training or may not have access to broader humanities and social sciences if we're talking about social computing. So the situation on the user side is even more opaque. So let's assume somebody has an information need, looking for a next book to read or a movie to watch, and this user is vaguely aware of the recommender system functions. He or she may or may not be aware of what goes into the input for machine learning, so whose preferences are being considered when he or she is being recommended a movie or a book. So some results are produced, but they're not necessarily explained. No justifications are provided for why this preference might be given to a particular book or movie or a set of them. In addition, the mechanism for how this verdict was rendered is either behind the know-how screen or is just overlooked altogether by the developer. And the general accountability for the system is lacking because it hasn't been explained in a particular application context. What are the governing forces? What are the sort of salient features that went into the decision rendered by the machine? So in this panel, we are calling for greater transparency in AI systems. And why does it matter? So if we were to coexist with algorithm mediation of information in online environments, if we were to accept automated verdicts and make use of the system, adopt them, and actually follow through with their suggested decisions, we need ways to assess these kind of AI technologies. We need ways to hold developers responsible for the decisions that they offer, even through the mediation of the AI. In turn, these kind of assessments and verifications could lead to revealing flaws in the system, revealing flaws in a broader system that governs the development of AI systems. And that's fine, because the more we learn about artificial intelligence, the more we learn about human intelligence, and we learn about inherently human processes. And the more we are able to provide these kind of assessments and look into verification, the greater the chance of increasing the trust in the systems themselves. This introduction is now going to be followed by 5 mini talks. Dr. Jackie Burkell will talk about external requirements that system outside of the computer science development might impose on the AI system, and she's referring specifically to the judicial system. Danica Potts will talk about internal expectations that users might have from machine learning, especially in the context of categorizing human personal data. Tolu Asubiaro will talk about how we experience artificial intelligence with recommender systems. Sarah Cornwell will address how opaqueness may be built into input data in terms of biases and stereotypes and various ambiguity issues in language. Yimin Chen and Chris Brogley will have a shared talk about one of the examples, the prototype system that we build at the lab to be able to identify clickbait in the news as part of the effort towards news verification in online environments. And they will bring potential solutions towards how a system could be made more transparent. Having said that, we don't have all the solutions. We just have a lot of questions to keep asking, and we're looking forward to your input. After a brief summary of these talks, we'll go to a live discussion on Zoom as part of CASE 2020. Thank you for your attention.